We continue our discussion on Reynolds transfer theorem. But now we would like to change the value of n here, not about the mass. So we change into force. So let's say, this is the general Reynolds transfer theorem equation. We already learned this in previous lecture. We have dn system dt is equal to d dt control volume of rho b d volume, and integration of rho b vn and dA. And then in this discussion, we want to calculate a force. Means that the dn dt here must equal to force. So the idea is force is equal to ma. And then we want to split because we have a dt here. So we split into m times velocity divided by t, because velocity over t is actually the acceleration here. And then we could say that it is equal to mv over t. Now the n system here is m and v. M and v here is the momentum. That's why for this discussion, in many textbooks they will call as a momentum equation, because we are dealing with momentum. Why? Because we already have one t outside the equation. When we divide into times, we could get the force. In this situation, if the ns here is momentum, it is must be written as mv. And then if we check the equation here, to make sure that the equation will reflect the force. Okay, we have already have t here. And we know that rho and volume here is actually equal to mass. Means that the b here must be velocity. And then again here, rho a and v is the mass. And then we need to make sure that the b here is velocity, because we want to calculate the momentum. To simplify this idea, if we want to calculate dn dt is equal to force, we must make sure that the n system here is momentum. And then to make sure that all of this term will give us about momentum, about force. And then we need to change b is equal to velocity. In previous discussion, we make the value of b is equal to 1. But when you want to calculate the force, or you want to do the momentum equation, you must make sure b is equal to velocity. And then this is the Reynolds transfer theorem, the general one. We have the dns dt, which is equal to force, which is equal to ma. And then we split the acceleration into velocity and time. We have this term. And we have this one. And then we need to change the b here into the velocity. And then this is the second terms, which is the integration of control volume. It will become rho v dv, and the integration of control surface will become rho v vn and dA. What is the difference between this v and this vn? This v is the velocity according to x and y axis. However, the vn here is the velocity according to the n vector. So n vector is depend on the cross-sectional area. So for example, if we have a pipe moving like this one, so this is the control surface. So and then we need to draw the n vector this this direction. So the value of vn here will become positive v. Okay. However, the velocity of x direction here, you need to use your trigonometry to calculate the velocity on x direction. So this is the difference between v and vn. So and then what you need to know is the V and Vn is not the same. So and then the symbol of this one is the volume. So normally in handwritten, so I advise you to write like this one. So V with bar here. So it is volume, but V is the only V is velocity. So and then in this situation, we will focus on incompressible and steady flow. So velocity of fluid did not change with time, so means that the integration of control volume rho v and dv will equal to 0. So this is the most simple, most common assumption used in momentum equation. So means that the equation here is now can be reduced into this term, because the idea of control volume is not affected the equation. So we could write some textbook, they will write the final momentum equation as this one, means the sigma of F means total amount of force. It is equal to the integration of rho v Vn and dA. So in some textbook, they will use not integration, they will use the sigma, mean total force is equal to the total equation like this one. So this is an equal mark here. So the total of rho AV, Vn, rho AV and Vn. So and then it is equal to rho AV here, it is equal to Q, which is the volume flow rate.